Welcome back to Black Robot. Today's topic is array, string, and pointers in C. These three topics are the heart of the embedded system programming because they deal directly with memory and data handling. By the end of this session, you will know how to store multiple values, work with text, and handle memory like a pro. Why arrays? Imagine you want to store marks of five students. So you have two options. Option one, use five different variables, mark one, mark two, and mark three. Okay, mark one, mark two, and mark three. This is option one. And you are having option two, use an array with the marks five. Okay, so arrays allow us to group values of the same type under one name. Okay, so this mark one, mark two, mark three should be same size. Same size means int of something like that. Okay. So this will group into the marks file. Okay. So it allows storing multiple variables means under those variables you are having values of the same type. So this is what array is basically. Okay. So in that case, I will give you one example here. So suppose you are having in marks 5 is equal to 1, 2, 3, 4, 5. So these are the collection of elements which are storing into the 5. It is storing basically onto the position 0, 1, 2, 3, 4. Okay. So this is, you can say real life, example is a row of lockers. So in that case, each locker has an index number just like array elements. Okay, so 0 to 9 you are having those numbers, so which is storing the particular numbers and storing in this group of numbers. Okay, you can make it those combinations inside that. Okay, this is how array you can define and store. Okay, what if it is character? So in place of int, you can write char. Okay, so how you can change the data type as well of the arrays. So, declaring an array, how you do the declaration? Just, you define the data type integer, the array as a variable. So inside that variable, you are having the five elements. So these five elements, if suppose you are having 10, 20, 30, 40, 50. So always you define these arrays under these brackets. Okay, curly brackets are there. So you have to define like that. So array zero, if you are seeing which element is having 10. Okay, array one, which element is having 20. So like that, array four, which element is having 50. So it always starts from zero to a number. Okay, so this is how you can access the element. So this is the position you need to define inside this square bracket. So 1D array. So it's a one dimension array. D means dimension here. Okay. I think you have studied into the mathematics 1D, 2D. Okay. So these kind of arrays. So how you store, how you print or how you enter these numbers So how you do that? So firstly, what you will have to do, you have to, initialize with the marks which is having here 90, 85, 90, 88, okay, 22. If you want to print this, how you are gonna X using the for loop. So firstly, using the for loop, initialize with the zeroth position, it will go less than 5. Less than 5 would be 4, right? So, so it will initialize from the 0 to 4. Okay, so once suppose 0 has come up under the marks, so it will become marks 0. So mark 0 would be having 90. So marks 1, it would be having 85. So like that, if it will, this number I will increment till 4, what would become marks 4? It would become 92, correct? So this is how you print it. So I will, give one task here. Okay, how to store or insert these numbers using scanner. So I'm giving hint. You use the scanner for storing the number or enter the number. Use this and try from yourself. Okay, if you are having question, any question, any doubt, you can comment under this comment section. So, in that case, what you got to know, array and loops make it easy to process multiple values. Okay. So, what are the common mistakes we do basically there? Common error, accessing out of bounds element. What if you are, accessing, you want to just going for the fifth element and you are having only 0 to 4 element, it means total 5 elements. So it will you will get the undefined behavior there. So in that case you will get to know. So so in embedded systems, what will happen? It will crash. Okay, it will crash because it is going away the limits. So it means this can cause crashes in embedded system. So always stay within the limits. Okay, always access within the limits. If static the array always have the static number, right? So static places as well because you are defining these things. So this is the common mistakes. Avoid these common mistakes if you are doing the programming into the embedded systems. Okay, and you will not get anything there. Okay, it will crash the memory. Then coming to the 2D array. So 2D array, how you define it? So under 2D, one. So under one, two, then three, four. So this is 2D, right? Basically, two-dimensional array. What is row and column here? This is row and this is column, right? So 1, 2 is the row and 3, 4 is the column. So how, so this is basically you call 2 into 2 matrix. Okay, because it is having two row, two column. This is 2 into 2 matrix. So for coming to the example of 2D array here, how it would become. Okay, so suppose you are having A. So one, 2, 3, 4. So this is row 0 and this is row 1. For B, it would become 5, 6, 7, 8. Row 0 and row 1. So how it is going to access it? It is on to the position 0, 0, 0, 1. This is 1, 0 and 1, 1. This is the same 0, 0, 0, 1, 1, 0, 1, 1. Okay. When you are just going to add these things, how it would work here. So first thing you wanna understand uh, how these for loops are working. So there is multiple for loops here. So in that case, for it is initializing with the I is equal to 0, which is I is less than equal to 2, because we are having 2 into 2 matrix here. In that case, I plus plus, and inside that one more for loop you are having, this is j. Okay, so j is equal to 0, j is less than I plus plus, and aij, bij plus, and which will store Cij. Okay. So in that case, when I is equal to 0 is happening, so this is less than 2. So this will come up, I will become 0. When it is coming here, this is also 0. But and bij is equal to, this is also 0th position. So you have to see which is on 0th position. This is 1 and this is 5. Correct? So 1 plus 5 is equal to 6. So C on 0th position. Coming to the 0th 1 position, it what would become? So now this is 0 1 0. Now uh, this will increment to 1, right? This firstly this loop will run it before that, until it is not coming, false, it will not come out of this loop, and this loop will not run. Okay, so now it has become 0 1 0 1. Okay. So what is on 0 1 0 and 6? This would become 2 plus 6 is equal to 8. Okay. So vice versa, it will print here. So what would become 1 5 6 6 plus 2 8, then 7 3 10, then 8 4 12. So this is what C would be there. Okay. So this is also the 2 into 2 methods. So I think you have got the clear picture here for this. So how you pass the array? Okay. So passing the array, in that case, you have to define into the argument array of this element when you are passing this array into the function, and size of the array as well. Okay. If you are not defining size of the array, you don't know what is going to, assign those values. So those will be the garbage values. Got it? So how you are assigning these values? So in that case, if you are passing, okay, this int array here. Okay, so suppose you have array of having 5 elements, right? So these 5 elements is just 1 2 3 4. So this is collection of elements you will pass here. Okay, from some other main function. Is print array inside that array. Something. Okay, so when you will pass it, these collection of elements pass here, and parallelly you will have to define the size for it. Okay, so it will just enter here. So this is how the passing of array will happen. Got it? Now coming to the memory representation, how the memory representation happens into the array here. Arrays are stored in contiguous memory. Okay, so suppose 1 2 3 4 5 6 7 is given there, right? So it will store first here, then 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 there. Okay, so this is how contiguous memory location will happen. So you can see array of I is equal to pointer of array plus I. You can define it. These both are equal here. Okay, so we will talk about pointer later. Okay, so if array is at AR, array is at on array 0 is at address, because pointer denotes to address. Okay, so if it is denoting to address position, okay, so array 1 where it will uh, denote, where it will denote here. So it will be, onto the 1004th position, because int, if you have defined as an int, okay, Why it is 1004? Because integer is having 4 bytes of size. Correct. So 1000 plus 4. It will become 1004. So array 1 would be on to the 1004 memory location. Okay. So what is, you know, there? Array is equal to rocker of columns here. Each locker is all having, real life analogies we are seeing here. So each locker having a number you will be having index and each locker can be the elements. So items are stored next to each other. So this is real life you can implement also in your code. Okay. Then coming to the string picture, what is strings here? Strings are array of characters ending with the slash zero. So this is the array of characters ending with the slash zero. So this is what a string is. So you have to define as a char and a string array. Okay, and hello world. So inside a double quote, you need to define it. So it will be stored as a hello slash zero. Okay. So if you are seeing here, okay, how it is declaring on you can store into the two ways, either using the double quotes or either using this method. So declaring the strings, you are having two options how you are going to define it. So this is on to the zeroth position. Then first, if you are going to access, the similar way is that one only L, okay, two and third and fourth. Okay, and this you are having as a end of the string here. So what is null terminator? Null terminator basically marks the end of the string. So without it, program may read garbage values. Okay. So you will have to keep in mind when you are using the string here, string implementation. Always it must end with the slash zero into this. Okay. So always keep in mind about it. Okay. Otherwise, you will be having the garbage value. So how you read the strings here? You can use the scanf. So for string percentage, you always use. So for str, you can the variable you where you have stored the string value, you can use here. So this is what scanf is there. Get str also. So basically, it is risky to use, but you can use this. Okay. Puts str is also there. It prints the whole string. So I think updates is the best choice. You can use it because one more is not given. I've get plus is given there. Suppose if you are using a variable name with the size 20, okay, so it's safer to use. You can use it for your implementation when you are, you know, taking this one. So how you define it basically character. Suppose you are having the character and a name here with the 20 elements having. So you can use the scanf with the percentage, okay, which we have discussed here with the name. Okay, with the name you are going to store in these 20 elements and you can use the fgets. Fget s, okay, name with the 20 elements and also studio. So these things you can define it. Okay, this is safer. How you want to, get the length of the string, you can use the strlen. Okay. So suppose the 10 elements are there, so you will always get the 10 as a count. So strlen counts characters before this null terminator. Okay. Then coming to the str copy, this copy one string to another thing. So suppose str copy you are using here, so destination you have used. Okay. So in that case, source which you have given, so suppose source you have given A, B, C, correct? A, B, C. It will store into the destination part here. So in that case, character is given there. One example also I'm giving here for your better understanding how basically we copy this. Okay, character is one element which is having, so xt or copy is given there inside that s1. So destination is this s1 is here. What how we can hello. Okay, this you will print it. Coming to the compare part, how you compare true string here using the S1 strcmp, strcmp. So you can, compare these S1 with this S2. If it is equal to these two one, so you will get the return zero. So like we discussed about the password check about the ATM as well. So how you will do that if strcmp, okay, variable is having the password here. If you are typing with 1, 2, 3, 4 equal to 0. Okay. So you can print as login is successful. Got it? So this is how you can compare the two strings. STR concatenate is there. Okay, so strcat you use for concatenate string. So strcat you basically use it. So how you go for that character? Suppose you have given the char name, okay, with the 20 here, the something. Suppose you have taken some string here, like and str cat. Okay, so name would be name and robot. Okay, you want to add it. So this will concatenate with the back one, and you can what it would become black robot. Okay, so this is what it would you will get. You can try by yourself. This is small, programs. So this we have talked about how simple login check using the strings. So this you have to pass it here, and you can compare and you will get the login successful. String versus character array. So string, end with the null termination, but character may not with the slash zero here. Okay. So string is basically is equal to character array plus slash zero. Okay. So you will get it. So without slash zero, you will not consider the valid string. I think always keep in mind here. So real time, what can be the real life example there and login? So string can be based on the thread. Each bit will be having character. So in that thread, null terminator to hold them together. Okay. So null terminator to hold them together. So there would be the thread for each character. Means that slash zero is responsible to holding them together. Now coming to the pointer uh, section here, this is also so much important for the embedded systems as well. How work, how you assign the value, and how uh, address works, how value of address works here. So pointers is basically variable is storing address of another variable. So that is having variable and storing address of another variable. Got it? So it basically stores the memory address of another variable. So suppose what this is how you define it, but we will go more into the details here. How basically you use it. Int, suppose you are having int x is equal to 10. Okay. So int pointer p is equal to and x. It means it is having address of in this one, correct? So you can see slightly here how it is happening. So this is, you know, and is the address of the operator which is having address here into the P. Okay. And the pointer is the reference of the operator. So when you will print here into P, so you will get the 10 here. Okay. So you can retry, suppose so how you will print it? The print will be, so you'll be using the pointer with the p because you are dereferencing this p or p variable here. Okay. So always use the address of the those variables. So that's why it is very much important keeping in mind how you are using the memory uh, access things into the embedded systems. Okay. Suppose if you have just removed it, right? What will happen? It will crash it, and nothing will happen, right? So that we always have to keep in mind about these things. Now coming to the pointer one, how this is how we have discussed, right? So x is equal to 0 and it is storing and x and it will print 5. Okay. Now pointer arithmetic, how it is incrementing the values inside the pointer. So suppose array you have defined it array 3, 10, 20, 30 inside that. And as a array into the pointer p, you have, assigned these values. So what will happen with the address? So with the address pointer point p plus 1, okay. So at int, because it is having suppose 1000 memory, okay, first. So in second, it has incremented with the 4 bytes because it's an integer value, right? So on second position, what is having on 1004 one? Okay, it is having 2. 1000, it is having 10. 1008, it is having 30. So when you have reached to the fourth one and pointing to this address, okay, so you will get to 20, right? You will get 20 here because it has incremented by with a 4 byte. So you will get this one. So this pointer is pointing to this memory location. So this is how pointer works. So array and pointers, you know how it works. Array name is pointer to its first element. Okay. So suppose array name points to first element. Just now this is how address goes because pointer is indicating to the address there. So in that case, the zeroth element will go to the zeroth, one with the ARR plus 1 and second ARR plus 2. This is how indication is happening with this one, with the pointer. So value at address is always different. So how string and pointer works? So we will go more into it. Suppose you are having, you know, flag robot as a pointer field. Okay. So with the address, value at address on a pointer, it is having as a block robot. So when you are going to print it onto the first pointer, it will print here the not whole one because it is indicating to the first element only this pointer, right? So this address is pointing to the first element. So that's why it will store the B here, not ours. Then how? So this is string and pointers. How you relate? Okay. Then pointer to pointer, how you relate? Suppose you are having x is equal to 0. This address, okay, this address of x is storing here value at address p. So value at address p. So 10 is stored here. When you are storing this thing, okay, then And if we Mm, because now it is value now address of p it is having 10. Now it will store into the value of now it will store at the value of q. It means value at address q, which is dereferencing this q here. It will have the 10 here. So double q, star, which it is denoting here, dereference here, it will have the 10. Okay, this is how you define. Okay, so this is what is basically and here. This is address, address of. And what is this one? Pointer. This is value at address here. Got it? So address of value at address. So address of x is assigning with the value out at address c. Okay. So this is dereference. We are dereferencing the things here. We are dereferencing here. So that's why you have got 10 here. Now array wide and null pointers are given there, right? So what is wide and null pointer? So basically you always get these questions into the interview. So for interview perspective of view here, you always have to remember what is wide pointer, what is null pointer here. So wide pointer is generic pointer and null pointer is the empty pointer here. This is how empty pointer you need to define it. Generic means nothing is defining it initializes is with the void here. Okay, void. So this is what void and null pointers. So for example, if you in pointer p is equal to null, so if p is equal to null here, so you will get a print f into p pointer. What is dangling pointer? Pointer pointing to freed memory. So it is dangerous into the embedded systems. So always try to free the memory there. Otherwise, it will dangling will happen. P is dangling here. So whenever you are using malloc function dynamic memory, so you will always have to free the memory there. Okay, always keep in mind for the embedded systems. Pointers with functions. So it is called by reference here. If you're saying this is called the call by reference, pointer A and pointer B here. Okay, so this is called by reference. We basically call it. So how it will happen there? So in that case, suppose into the main function, uh, you are having swap. You are calling this swap function. So you will just input this and A and B. Okay, it will just pass it here. In pointer A, pointer B. So you are having some below equal to 40, anything. Got it? So this is how you will go for that. So pointer with strings, how you gonna print it? So here you are seeing character str with the black. It is storing the black here, and into the pointer P you are having the str. Okay. So in pointer P, if that is not equal to you know if it is not equal to /0, it will always print this, and Pointer p, this is incrementing here with the p plus plus. So address is incrementing. That's why the character will print as blue L A C K like that. Okay. So this is you can try by yourself and see how it works. So dynamic memory location. So what is dynamic memory location here? It basically malloc allocates the memory and free is responsible to free the memory there. So important for IoT and embedded system because memory is limited there. So that's why in most of the cases we use these terms into those embedded systems and you know embedded systems and IoT. So, what is malloc? Malloc is basically allocates the memory, okay, and freeze releases the memory there. So, in that case, how happening? If you're seeing here, we are defining with the int pointed p is equal to integer pointed, okay. So, uh, so for that. For these dynamic memory location malloc is having size of 5, okay. So size of 5 into integer of size of integer, so it means the size of malloc would be 5 into 4 20 would be here, okay. So in that case you will always have to see how size you are defining inside that, got it. So in that case suppose you are having the size array 1 2 3 4 5, correct. So 1 2 3 4 5 6. If you don't need these 5 6, how you gonna do that, right? This memory location 1 2 to 4 only you need it. So that's why till integer size of integer it will go for the 50. So 1 2 3 4 it will become 4 into 4. So it means 16 bytes, right? So this you need as a memory location here. So basically, you allocate memory at the runtime. Okay. So you allocate the memory at the runtime for this. So giving you the ability to handle the data of varying size. So dynamic resources are stored into the heap memory instead of the stack. So this is stored into the heap memory, not into the stack. Okay. Because it runs onto the. And second case for a dynamic memory location, the size of the array can be increased if more elements are to be inserted and decrease of less elements are inserted. So that's why it is dynamic in nature. So there is no need to, estimate the maximum possible size. So the size can be added, at the running time according to the requirement. So, in this dynamic memory location, when you're going to the malloc, so malloc is basically used for the allocate the single block of contiguous memory onto the heap at runtime. So that's why malloc we use here. Coming to the second thing, I haven't mentioned here calloc. Calloc. Why calloc? We use that, right? So that's also the thing. So Kellogg stands for contiguous allocation. So this is how it has difference than malloc. So it means function is similar to malloc, but it initializes the allocated memory to zero. So that was allocating initializing with the garbage value, but here it is initializing with the zero. It is used when you need memory with default value is zero. So that's why Kellogg is use it. How it is defined? Kellogg. Okay, n size. What is n here? N is the number of elements. Okay, number of elements here, and size you have to give it. And size of each element into the byte. So this is how Kellogg you define it. This function also returns a white pointer to the allocated memory that is converted to the pointer of required type to usable. If allocation fails, it returns null pointer. Okay. So this is how Kellogg define how you basically do. you know, uh, defined with the integer, suppose int pointer p, so is equal to int pointer, so when I said in that, alloc is given there, so 5 and size of int. So this is how you define the alloc here. So this is also having the difference there. And after malloc and calloc, free. We use the for releasing the memory. Why we use the free? The memory allocated using functions malloc and calloc is not deallocated on their own. It doesn't deallocate on their own. So the free function is used to release dynamic memory location back to the operating system. It is essential to free the memory that is no longer needed to avoid memory leaks. If you are not freeing the memory, so there are many more chances there will be a leak in memory. Okay, so if you are working onto the embedded systems, IoT projects onto the controller side or processor side, keep in mind about this dynamic memory location. Okay, so you use the free PTR, where PTR is the pointer to it means here we have used the p, so p you can use it. So is the pointer to allocated memory. It is freeing that. After freeing a memory block, the pointer becomes invalid and it is no longer pointing to a valid memory location. So after freeing the memory, it the pointer become invalid there. Okay. So there's one more thing is given there. Okay, realloc. What is realloc there? Realloc function used to resize a previous allocated memory block. It allows you to change the size of an existing memory location without needing to free the old memory and allocate a new block. Got it? It means it allows you to resize the of an existing memory, allocating without needing, to be free the old memory. It means there is no need to free and allocate it. You can allocate, into the previous itself. How you use it? So for that realloc function here, you can use it here. So pointed p and new size you can use it here. So where pointer p is the pointer to previous allocated memory block and new size the reallocated size into the memory block should have in bytes. This function returns a pointer to the newly allocated memory or null if the relocation fails. If it fails, the original memory block remains unchanged. So this is how you use the reallocate. Okay. If you are having any doubt, you can comment below into the comment box. I think you have got all three topics. Okay. So array string pointers are backbone of the embedded C if you are doing programming. So what real life, analogy house of address is there as a pointer you can consider and variable as a house. Okay. And address where house is located. You can go for that. And what is pointer to pointer? A map that points to another map. This you can consider as a pointer to pointer. It means the pointer you can consider as a house address, correct? And variable is a house and address where house is located. And what is pointer to point? A map that points to another map. So this is how you can relate to get those things. So uh, So in that case, what we have studied, okay, so studied in this lecture arrays store multiple values into the contiguous memory strings, special characters, arrays ending with a slash zero, pointer, variable holding memory address. So together they are the backbone of the memory handling into the string. Okay, so that's it from my side. Thanks, thanks everyone. And if you are having any question and later on also we will discuss, we will be having boot camp for C, separately. There we will discuss much more in details about C after these, after this boot camp. So, but if you are having any doubt there, you can comment. I will try to reply into that comment. But yes, for details in C, stay tuned also about that. Okay, we will discuss about much more detail about these things as well. So you will get much more clear picture into those lectures about the C.